Hello, everyone. In this lecture, we are going to look at an exercise about effectiveness of an insect site. As part of a cost-effective study, a wholesale florist company ran an experiment to examine how well the insecticide rotenone kills an aphid called the microcyphonina sambroni. So this is just a um, uh, this is an insect, and this is an insecticide. Now that feeds on the this kind of chrysanthemum plant. Okay, the explanatory variable is the concentration. So the insecticide we put in different concentrations. Those are the different concentrations in milligrams per liter of the insecticide. About 50 aphids each were exposed. So for this one, we have 50, this one we have 48, but we have about 50 in each experiment to one of the five concentrations. Each insect was either killed or not, okay, are not killed. Here are the data. Please calculate the proportion killed, odds, and log odds. So this is the number of insects in this experiment, and this is the number killed. So what's the proportion of killed, and what is the odds, what is the log odds? And after doing the calculation, observe the relationship between log odds and the explanatory variables. I mean, this column, this will be your explanatory variable or predictor. This will be your response variable, y. So what does the relation suggest? Now let's do it. Now this one we can do it with uh, with Excel. I have already put Excel over here. So we have 0.96, 1.33, 1.63, 2.04, 2.32, and then we have 50 insects, 48, 46, 49, and 50. How many of them are killed? There are 6, 16, 24, 42, 44. So this is a concentration. The next one is number of insects. And this one will be the number killed. Now we need to calculate proportion killed. Let's do this. Proportion killed, and let's make sure they are centered. Now, proportion killed, we need to use, this one is actually equals to 6 divided by 50. So let's do it. It's 0.12. Now let's select this corner, and we do the same formula for all the rows. And let's maybe just use maybe 3 digits. Maybe just use 3 digits. Now odds. Odds is proportion killed success point, like should equals to this one divided by 1 minus E3, P over 1 minus P. So this is, let's do the same for the other rows. Put it over here. Yeah, E6. This is E6. 1 minus E6. Let's put it in there. Okay, let's put 3 digits over here. Now log odds. Log odds will be equals to log, and we use natural log, and this will be minus 0.853. Okay, Now let's observe the relationship between this is x, this is y, and what we are going to do is we are going to insert. Let's insert the chart. Okay, the first one. See the first value. The first value should be 0.96 minus 0.8, 0.96, right? X is 0.96. So let's add data labels. X is title. So this should be concentrations, right? So X should be concentration, and the Y should be log odds. And we can see, can we add, let's add a trend line. Yeah, this is a trend line. So if we drag the log odds and we look at the number queued, this will be different because you might have different number of insects. So it's better to model the proportion queued. And then we go to the log odds, So this experiment actually illustrates the concept of how to calculate the proportion, the probability of success, and the odds for a particular sample. This sample has 50 insects and 6 got killed, and the next one, different concentration. So what we want to study is how concentration impacts the log odds of killing the insects. So the relationship suggests that there is a linear relationship. Then you can do the logistic regression, predict the log odds from the concentration. That is log odds equals to beta 0 plus beta 1 x. Okay, so this is the end of this exercise.